there are four main things when we want to look for a substituted cycloalkanes. So the first one is the prefix, plus the cyclo part, then plus the parent, and I'll go over what this means in a minute, plus the suffix. So when we're looking for the prefix, we want to look for what and where the substitutes are. When we want to look for the cyclo. The cyclo is pretty simple. It's just the means a ring is present. It is present. When we talk about cyclo, that just means is there or is there not a ring or a circle involved? So, is there ring involved? So, and then when we talk about parent, that is how many carbons are in the ring. So, how many carbons are in the ring. Oops. And then for the suffix is what is the functional group, which would be, let's just do an example. Find the parent cycloalkane. So if we have one that's just like this, just drawn like this, and we have CH2CH3, and then one coming off here, which is just CH3. We count how many parents there has, so how many carbons we'll have. So let's just count. We'll have 1, 2, 3, 4, 5, 6. So in total we have 6 carbons in the ring. That's going to equal to cyclohexane. So let's just do step 2. Well, not step 2, but step 2, which is name and number the substituents. Remember now, no number is needed to indicate the location of a single substituent. So let's just draw out an example. So if we had one that goes like this, and then we have CH3. So because we have no one, we just have one. We don't need to do any extra numbers or add any extra numbers. So this is going to equal to methanol is going to equal to methanol cyclo this is going to equal to methanol cyclohexane. You're probably asking me what right now. What is this doing here? Well, that is doing it. What's that doing is it's pretty much saying we have only one thing, one extra attachment added on. Because there's only one, we write methanol. So if we had, say, another one, CH3 over here, then that would be equal to ethanol cyclohexane. But since we don't, we just write methanol cyclopropane. So now let's have more than one substituted. We want to look for where they are. So for rings more than one substituted, begin numbering at one substitute and proceed around the ring to give the second substituent the lowest number. So let's just do this one, example 1, right here, and say this is example 1 too. But as you see, actually let's just say this is example 2. For example 1 here, that we went around and we want to do what they said, so we started out at this point right here and we went around and we noticed that it starts 1 and then it goes to 2, 3, 4, 5, 6. Over here we started out same spot, but instead we went a different way. We went on this side, so we did 1, 2, 3, 4, 5, 6. Now, what it's said to do is go around to name the second one the lowest. Well, let's see if which one's right. Our CH3 is located at carbon 1 and carbon 3. Over here, our CH3 is located at carbon 1, so that looks good already. But then our second one is located at carbon 5. So we know that something went wrong there. We know that this one is right because the second one, so this one right here, is located second to the lowest. Over here, this one is located at the 1, so that looks good. But you see, as we went around the wrong way, and that this right here is located at carbon 5. Well, 5 seems higher than 3, and we want the lowest, so we know that this one definitely is correct. The correct answer for this one, well, the written formula is 1,3 dimethanol cyclohexane. The reason why we have the 1 and the 3 is because the CH3s are located at position 1 and position 3. The di is because there's 2 of the CH3s, and then the methanol is because there's no other connected ones to it. I don't know how we get the cyclohexane. This one over here is going to be the same way we wrote this out, but it's going to have a 5 instead. And we know that's already wrong because we need the lowest number. We're going to do another example, which is right and which one's wrong. So we're going to do some notes here. So let's just say this is example 1, And this is example 2. So in example 1, our ethanol group, how we get ethanol is because this right here is equal to 2, which is ethanol. So our ethanol group is located at carbon 1. Our methanol group is located at carbon 3. And when we go over to example 2, we notice that our methanol group is located at carbon 1, and that our ethanol group is located at carbon 3. So we want to know which one's right and which one's wrong. Well, to find out which one's right and which one's wrong, we want to number the ring to assign the lower number to the substituents alphabetically. So that means that E comes before M, and so that's why we wanted to start out with our ethanol group as 1, and then go around as 2, 3, etc. And over here, you notice that our methanol group is located at carbon 1. Well, if we all know our alphabets, that M does not come before E, and that E comes before M. So we know that example 1 is correct. Now we want to figure out how to write this out, and so write it as 1 dash ethanol dash 3 dash. Now before I go further on, the reason why we write 1 ethanol is because in position 1 there's our ethanol group, and in position 3 our methanol group, that's where our methanol group is located, and we finish it off because there's 6 sides and it's in a circle. We finish off with cyclohexane. And for example 2, I'm not going to write it out because there's no point, because it's wrong. And just note that you need to go alphabetically.
Made with Doodlecast Pro.